In this video, we're going to talk about solving exponential equations where x, or maybe some expression containing the unknown, is all trapped up there in the exponent. My first example actually doesn't require a logarithm, but it's just because the numbers are nice. 64 is a perfect power of 4. 64 is 4 cubed. So if you make that observation, what we have is 4 to the minus x plus 10 is equal to 4 cubed. That'll only be true when the exponents are equal to each other. The base is the same, so the exponents must be the same. So this is actually just equivalent to minus x plus 10 is 3. Oh my goodness. That's delightful. Minus x plus 10 is 3. I'm going to go ahead and subtract 10 from both sides. And we get minus x is equal to minus 7. Multiply both sides by -1, and we get x is 7 as our answer. And we are done. I want to do this problem again using logs, because although there are a few problems in your 12.6 homework where you were given a perfect power of the base and you can be nice and clever, not all of them are like that, and so we need to practice using our log steps. All right, so let's do this problem again, but using logs. All right. So the first step is to take the log of both sides, either use the ln for natural log of both sides, or do log for common log of both sides. It doesn't matter. The reason why we're picking those bases, base e or base 10 respectively, is because our calculator has an log and an ln button on them. I'm going to go ahead and take the ln of both sides. Just so we don't feel afraid of those sets of symbols. I want to use them. Take the ln of both sides, or if you prefer, the log of both sides. So if that's your preference, going to get the exact same answer. I'm just copying each side, right? We took the ln of both sides. And I'm just noticing when I copied and pasted, I didn't keep that negative. That was our problem, yes? Yeah, 4 to the minus x plus 10. Okay. Step 1 is still the same. Go ahead and take the ln of both sides. Or if you prefer, the log of both sides. Step 2 is going to be to use the power property, and we're going to take this whole exponent down in front using our power property. Because that has two terms, I need parentheses. That whole exponent times the ln of 4, and you can choose to write parentheses around here if you want, is equal to the ln of 64. Right? All right, so we just used our power property. And now it's just time to solve for x. It looks a little intimidating, but remember, ln of 4 is just a number. Ln of 64 is just a number. So this is not much different than like minus x plus 10, I don't know, times 2 is equal to 11. They aren't those numbers, but it's not any different. I want to divide both sides by this number. Yeah, so I'm just going to rewrite it. Minus x plus 10 is all being multiplied by this number. I'm going to do the opposite of multiplying by this number. I'm going to divide by this number. What I do to one side, I have to do to the other. Right? So we're just solving for x. We just divided both sides by the ln of 4, which, let's just convince ourselves, yeah, that's just a number. It's e to whatever power is 4, right? So function ln of 4, it's about 1.38, yeah? Or 1.39. It's just a number. So now we've got minus x plus 10 times the ln of 4 divided by the ln of 4. That's a 1. Did that on purpose. That's equal to the ln of 64, all divided by the ln of 4. Now I'm going to just go ahead and subtract 10 from both sides. And we're almost done. Minus x is equal to the ln of 64 divided by the ln of 4. That's one number divided by another number, and then all that's being subtracted from 10. I'm going to now, how about we multiply both sides by minus 1 so that we have positive x? That's not, x is almost by itself. All right, so close, so close. So we have x is equal to minus 1, or just minus the ln of 64 divided by the ln of 4. Minus a minus 10 is plus 10. And really we're done. Order doesn't matter in addition. So this is, I know it looks crazy, but that's just one number plus 10. I think this looks a little bit nicer. 10 minus that number. This is fine too. Here are our exact answers. Now, we already did the math and we found out that x was, because it was, I gave us a nice simple problem. Well, I shouldn't say simple, but I gave us nice numbers where we didn't need the log, right? And it turns out that x is positive 7. Let's see that that's the case using our calculator. All right, so our answer was 10 minus this number. In the numerator, we had the ln of 64. In the denominator, we had the ln of 4. Aha! Look at that! Isn't that cool? 7, right? And if you, instead of taking the natural log of both sides, if you prefer writing log for common log, you're going to get the same number. 10 minus, numerator will be log of 64, denominator log of 4. Beautiful! 7! Awesome, awesome, awesome. So the reason why I wanted to do this problem both ways is that, one, if you're given nice numbers, like here, 64 is a perfect power of the base of 4, we were able to solve this without logs. But if you didn't notice that, or you weren't given convenient numbers, which is the case in your 12.6 homework. There's a mix. This will always work. What are your steps? You take the log of both sides. Either you choose to do ln or log, doesn't matter. You use the power property to bring that whole exponent down in front, and now you've got regular multiplication. We're now back kind of in very familiar territory. The thing is, like solving linear equations, you just do the opposite to both sides. You do those inverse operations to isolate your variable, your x. The thing that is just overwhelming here is that ln of 4, that's all one big object. It's one number. Yeah? And treating it like that takes some practice, but that's it. And lo and behold, when we put these answers in, this actually ended up being 7. But if we didn't have a perfect power of the base, that wouldn't happen, and you'd have a little decimal approximation. Okay? I hope you found this video helpful. Thank you for watching.